Okay, here's 4-2, day 1. And here's how I'm going to split it up in light of the learning target listed below. The objective is relatively straightforward, that we want to be able to use the unit circle to get trig values for certain angles. Okay, that's what we're after. In the first day, I'm not actually going to get to any evaluating. I'm going to leave all of that for day 2. All I'm going to do in this lesson is basically from scratch go through the patterns and where we get the values and the angles that show up in the unit circle. Okay, that's all you're going to see here. If you're really looking for more of, no, I get the unit circle, I've got it, I have a copy of it, I got to use it to get trig values, you'd be looking for day 2. Because here I'm just going to go through, and like my end product from this video is I want to have a unit circle, even though I'm going to split it up into 2 slides because I want to talk about the 2 separate patterns. So let's dive into that. I'm going to draw in an angle right here, make it a triangle, and this is kind of the first pattern that shows up in the unit circle. Now that radius is 1 because it's a unit circle, and these coordinate points right here are x and y, and of course the length of that side of the triangle is x, and that side is y. Got to make sure I leave room for the other pattern. Okay, now this is a really big thing, is because it's a 45, 45, 90 right triangle, I can call that side x because those 2 sides are the same length. Okay, and now one assumption I'm going to make as we do this, well, I suppose don't even have to make it an assumption. Cosine is defined, and we really haven't talked about this much, as adjacent over hypotenuse, which really leads to it being, if I'm looking from this angle, that means the cosine value is always the x-coordinate. Okay? And the sine value, because this side that is labeled y, that is opposite the 45-degree angle over 1. Okay, y over 1 is just y. That would be the sine value. Okay? So that's something we got to be clear on, because what I want to get from this situation, and I'll just mark it right down here. This is going to set me up for the unit circle. That's really my goal from this derivation, is to get the sine and the cosine value of 45 degrees. Okay? Now I'm going to do so by just using the Pythagorean theorem. Okay? But remember what we just established, that whatever I solve and get for x, that's the cosine value, and whatever I get for y is going to be the sine value. But wait a minute here. We already talked about how those 2 actually have to be the same thing. Okay, we're going to get the same thing. 1 squared is just 1. Essentially now I'm just solving for x, which is going to be the cosine value for 45 degrees, but I know the sine value is going to be the same thing. And we keep plugging along. I know there's a negative solution, but I'm going to ignore it for this case. It'll actually come up a little later. That would simplify to 1 over square root 2. And when I rationalize that, I get square root 2 over 2. And that might be a trig value from your experience with the unit circle that looks familiar. And there we have the sine and cosine value for 45 degrees. Okay? And that's kind of one of the patterns that the unit circle is based on. Okay? Now there's another pattern. that is based off of a different triangle. It's an equilateral triangle where all three sides are 1. So I could place this in the unit circle. I want to talk about two different angles actually. So I don't want to do that. All of the angles are 60. But I don't want to put in the top one because I'm going to cut it in half. Put in a right angle. Whoops. That is not what I wanted. I wanted to get rid of that. Yeah, so right here, that's 30 degrees, and so is this other side right here. Just reference that with an arrow. Now the other thing down here is it's taken these two sides and make them 1/2 each. Okay? Now obviously my drawing isn't very good, the scale. Both of those triangles should be the same. They're clearly not. And that's really what I'm after here, is to get h. All right? And now, the end result I'm after here, because once we have these, we're going to kind of jump over to the next slide, and we're going to start to build our unit circle. I'm looking at a 30-degree angle. And I want its sine and cosine values. But I need this h, okay? And I need this value for h because that's going to come up. Now I'm going to use the Pythagorean theorem again, and really the triangle I'm going to focus on is right here. Because I've got two of the three sides. So I use the Pythagorean theorem again. I get 1/2 squared plus h squared equals 1 squared, which is really 1/4 plus h squared equals 1. By subtracting a 1/4, I would get that h squared is 3/4. From taking the square root, I would get that it's the square root of 3/4, which would simplify to the square root of 3/2. Okay, and again, I'm looking at this from the angle right up here. Okay. The side that is opposite is 1/2, so I'm going to say that the sine value of 30 degrees is 1/2. This side is the one I just found, is the square root of 3/2. That's adjacent, so there is the cosine value. All right, let's put all this stuff together. Okay. Now, these two diagrams would form the unit circle, but I want to keep it split up off of the pattern. Okay. So I'm going to go around and split it up into these arcs. And for this one, I'm going to add the quadrant points. On the next one, I'm not going to do that because I just want to label them once. Like right here, Okay. The next thing I'm going to do is put the angles in radians. Okay. That's 0. This is all based on pi over 4. So this would be pi over 2, or 2 pi over 4. Here's 3 pi over 4 pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. Okay? Now the next thing I'm going to do is I'm going to go around and add the angles in degrees. I'm going to put them just inside. Okay, we had actually talked about this angle right here in degrees. It's 45. Here's 90. Here is 135. Here's 180. $225, $270, and there is $315. Okay. Now I'm going to add the trig values. Okay. Now remember, I'm going to go around and do the quadrant points because those are a little bit different. Okay. The coordinates of this point are 1, 0. Okay, so at 0 it has a cosine of 1 and a sine value of 0. Okay, these are a little bit different because they still follow the same pattern. They just don't technically form triangles. So that's 0, 1, negative 1, 0. And 0, negative 1. Okay? Now it's time to really get to the angles that we saw the pattern on. All that work we did on the first slide was for right here. That we saw that the cosine value, or the x-coordinate, was square root 2 over 2. And so was the y. Okay? And now this is a really big thing. As we move around the circle, all that changes from one quadrant to the next is the signs in terms of positive or negative. For example, right here in quadrant 1, I know both the sine value and the cosine value, the x and the y coordinate, are both going to be positive. All that changes over here in quadrant 2 is x coordinates are negative. Down here they're both negative in quadrant 3, and then over here in quadrant 4 the x is positive and the y is negative. Okay? So now let's jump over to 135 degrees, and I've got its cosine and sine values, same two numbers. I just have to throw a negative sign in front of the x coordinate. Down here, for 5 pi over 4, they both have to be negative. And then at 7 pi over 4, or 315 degrees, the x-coordinate will be positive, but the y needs to be negative. Okay? And that is the first pattern of the unit circle. Okay? The one that's based off of 45 degrees, or an angle that's pi over 4. Now let's split it up into 12 arcs. This is going to be pretty darn similar too. So here I'm not going to do the quadrant points because I did that on the other one and I just don't want to do them again. So what I want to go around, all I want is 3 things on this one, and this is actually where we'll finish, is, if we can go through and do the pattern for 30 and 60 degrees, we've got the whole unit circle. All right, here is pi over 6. Here's 2 pi over 6, or pi over 3. 3 pi over 6, or pi over 2 I'm going to skip. 2 pi over 3, 5 pi over 6. 6 pi over 6 would be pi. I'm going to skip it. Here is 7 pi over 6. 8 pi over 6, or just 4 pi over 3. We'll skip over 3 pi over 2. We already did that one. 5 pi over 3, and then 11 pi over 6. Okay, so we really have two things left to do here. Okay, and the next is I just want all these angles in degrees. Okay, here's a 30. Here's a 60, and now again you can just go and keep adding 30 degrees. That means that this one right here has to be 120. 150, I'm going to skip over 180. Here's 210. 240, I'll skip over 270. Here is 300. And then here's 330. Whoops, not 333. .333 actually isn't on the unit circle, believe it or not. Okay. We're going to go add the sine and cosine values, and that's going to be it for today. But before we do that, I just want to give us a reminder that with these quadrants, this is what it's all about. You know, we've got the numbers that we need. 1/2 and square root 3 over 2. Everything is going to be based off of that. It's just a matter of changing the signs. Okay. Now the one we could already fill in was 30 degrees right here on our first slide. When we were working with that diagram, we had figured out that that was the cosine and the sine value for 30 degrees. Okay. Reflect that over to 150, and that would be negative square root 3 over 2 for cosine, and have a sine value of 1/2. Now reflect that down to 210 right here, and you would have negative square root 3 over 2 and negative 1/2. And then reflect that over to 11 pi over 6. Notice how the ones that I'm filling in are all based on pi over 6. Okay, those are all the ones that are following the same, like the same cosine and sine value, just the sign is, you know, is changing. X coordinates positive. And the y coordinate's negative. Okay, square root 3 over 2 and negative 1/2. Now you could certainly go back to the diagram and check if you wanted to, but what happens with 60 degrees is pretty straightforward. You might even recall it from seeing the unit circle in the past. Okay, go up to pi over 3, and what happens? It's the same pattern, except the two coordinates are switched. If you went back to that diagram and you looked at a 60-degree angle, you would just see that, you know, those two trig values that we found, they just end up switching from 30 degrees. Okay, so now I'm looking at all the ones that are based off of pi over 3, and I'm filling in the same pattern that over in quadrant 2, 1/2 needs to be negative. Down to 4 pi over 3, down here both need to be negative. And then over to 5 pi over 3, the x-coordinate of a half is positive, but the y-coordinate must be negative. And I believe that's it. We have ourselves a unit circle. We derived the whole thing, right, just based on the patterns of 45 degrees and 30, 60. And we've now got our unit circle. And again, where we're going in day 2 is, all right, that's great. That's kind of a one-time thing to go back and see where all the trig values come from. Let's use our unit circle to find and evaluate trig values.